Today we're going to be talking about simplifying complex rational expressions. And what do we mean by complex rational expressions? We mean rational expressions such that within the numerator and within the denominator there are more rational expressions. So for example, in this first one we have 4 plus 3 over x and 1 minus 2 over x. And that is a complex rational expression because you're going to have to do a lot of work either simplifying the numerator first and simplifying the denominator first and then simplifying the whole expression, or somehow sort of clearing all of the denominators. And that's what we're going to get into now, is those two basic methods for simplifying. So the first method is probably the most mathematically intuitive, which is just to remember that if you have fractions within fractions like this, that big fraction bar implies that there's really a parentheses around the numerator and a parentheses around the denominator, and you're going to simplify within the numerator and simplify within the denominator first. So that's what we have here on the left hand side, is if you were focusing in on just that numerator of 1/3 plus 1/6, you would notice that within those two, their least common denominator is 6. 1/6 is already over 6. 1/3, you would have to multiply both the top and bottom by 2 to make that. So then you would end up with 2/6 plus 1/6 on that numerator. And then for the second fraction, or set of fractions I should say, for the 1/2 minus 1/3, you would again notice their least common denominator is 1/6. So the second one you would have to multiply by 2. The first one you would have to multiply by 3 to end up with 3/6 minus 1/6. Then you would still have to keep on going, so you would have to simplify within the numerator and within the denominator. That numerator, 2/6 plus 1/6, will simplify to 3/6. 3/6 minus 1/6, that's going to simplify to 2/6. And then whenever you have a fraction divided by a fraction, aka what we have here, then you want to make sure to keep change to multiplication and then flip, aka dividing by a fraction is the same thing as multiplying by the reciprocal. And 3 times 6 gets you 18, divided by 6 times 1 gets you 6, we'll end up with 3. Just for the sake of clarity of anybody rewatching or re-looking at these notes, I'm going to erase this, but that was just me rewriting the steps that were already typed out for you. That is actually quite a bit of work, as you noticed. It does work, it is mathematically sound, but there is a shorter way to do it. You can notice the LCD between all four terms. So in particular, you're looking for the LCD between 3, 6, 2, and 3 all at the same time. Between all four of those, their least common denominator is going to be 6. Then what you can do straight away is multiply each and every term by 6. And really you're multiplying each and every term by 6 over 1. As long as you are multiplying every single term by that, you're good. So you really are doing sort of 6 in parentheses and then distributing it to every single term. That's what you're actually doing. And as long as you distribute it to every single term, you're fine. Then you'll notice if you do 6 times 1 over 3 times 1, for example, 6 divided by 3 gives you 2. 6 times 1 over 6 times 1, 6 over 6 gives you 1. 6 times 1 over 1 times 2, 6 divided by 2 gives you 3. 6 times 1 over 1 times 3, 6 divided by 3 gives you 2. So you notice whenever you did that, you actually have no more fractions within fractions left. You can go ahead and just add those numbers on top, add those numbers on the bottom. 2 plus 1 is 3. 3 minus 2 is 1. 3 divided by 1 leaves you with 3. So if you can notice the least common denominator between all of the terms, that's going to be a faster way of solving these problems. So let's see that in action with actual variables. So you can do the first method, which is where you want to simplify it down to that you have a fraction divided by a fraction, and then you know that a fraction divided by a fraction is going to be keep, change, flip, so the same thing as multiplying by its reciprocal. And then you can just multiply across the top, multiply across the bottom. Wonderful. So let's say you had it with something like 1 over x plus 1 over y all over 1 over x minus 1 over y. Well, the first things you would have to do is just within that numerator, 1 over x plus 1 over y, you would notice that the least common denominator is xy. So the first term you would have to multiply by y to make it by over xy. The second term you would have to multiply by x to make it over xy. That would leave you with y over xy plus x over xy to give you a total of x plus y over xy, because those are two different types of terms, which is exactly what we have here. Very, very similarly, if you have 1 over x minus 1 over y, you would notice the same least common denominator of xy, so you would multiply the first terms by y, second term by x. And again, once you multiply both the numerator and denominator, you're not changing the value of the problem. We're really multiplying by y over y and x over x. That's just 1, so we haven't actually changed the value of the problem. So y times 1 will give us y, 1 times x will give us x times y gives us xy, and then we're left with that nice, lovely denominator. Then you would want to go ahead and rewrite that more explicitly as fraction division, because that big old fraction bar is the same thing as a division symbol. And that whenever you're doing fraction division, you're going to keep the first one the same, change to multiplication, flip the second fraction, which is exactly what we did here. And then you're just going to multiply across the top, multiply across the bottom. We're going to notice that this is really in parentheses, and xy divided by xy. That's going to simplify to make 1, and you would just be left with y plus x over y minus x. A faster way to do this would be to notice that the least common denominator between all 4 terms is going to be xy, because we got xy, xy. We're going to have to do x times y in order to make a least common denominator. So as long as we multiply all 4 terms by xy, we can then notice that our denominators are going to be cleared, because you'll notice in the first one, x divided by x makes 1, then you're just going to be left with y. In the second one, y divided by y makes 1. We're just going to be left with x, just like we wanted. For the next one, let me also re-highlight that. There we go. For the next one, similar sort of deal. X divided by x makes 1. You're left with y. Next one, y divided by y makes 1. You're left with x. And that was a lot faster to get to that final answer. So let's take a look at another one. So let's say you have 4 over x plus 1 over 2 over x plus 3. Well, the 1 and the 3, don't let that throw you off. Those are secretly over 1. So between x and 1, our least common denominator is going to be x. So we're going to multiply all 4 terms. Again, you have to make sure to multiply all 4 terms by that least common denominator, which is really that least common denominator over 1. We'll notice that whenever we have x divided by x, that's going to go ahead and make 1. And what you'll be left with is 4 over 1 is just 4, x over 1 is just x, 2 over 1 is just 2, 3x over 1 is just 3x as your nice, beautiful final answer. So I'm going to go ahead and encourage you to pause your video and try this next one yourself, and then we'll go through it. So here, the least common denominator is going to be xy again. So in particular, I'm going to have to multiply every single term by xy. And you should have as many xy's written on here as you have terms. Then we're going to notice what's going to cancel and make 1. X divided by x is 1, y divided by y is 1, x divided by x is 1, y divided by y is 1. If we did it right, there should only be 1's left in that denominator. And that will leave us with 2y plus 3x, because 2 times y is 2y, 3 times x is 3x, all over y minus x as a final answer. And then if this factored further, you'd want to go ahead and factor it. None of those terms factor further, so we are good to go. Go ahead and try this next one yourself as well. So for this next one, the least common denominator would be x squared, because the 1's are really secretly over 1. X times x will give us x squared, so that least common denominator is going to be x squared. So we're going to multiply every single term by x squared. And then we're going to note what's going to cancel to make 1. In particular, x squared divided by x will just leave me with 1x. X squared divided by x squared is going to leave us with 1. So what we'll be left with is x squared plus 2x all over x squared minus 4. Now this is actually a good example, before I actually box it in, that we actually can factor further, so we're going to want to do that. So within that numerator, x squared plus 2x, the greatest common factor is going to be x. X squared divided by x will leave us with x. 2x divided by x will leave us with 2. X squared minus 4, that's a difference of squares. That's the same thing as x squared minus 2 squared, so that will factor into x minus 2, x plus 2. And then we will notice that we actually have x plus 2 divided by x plus 2 to leave us with a final answer of just x over x minus 2. Now remember, in terms of the domain of the original expression, you would run into issues actually in multiple places. You would have to make sure that in terms of the absolute original that we're never dividing by 0, because that would make those inner fractions 2 divided by 0 or 4 divided by 0 squared. Both of those would be problems. And then for our newly made fraction, we'd want to make sure that x is never equal to 2 and x is never equal to negative 2, because that would make the denominator on our new simplified complex fraction 0, which would be a problem as well. Which is really just the same thing as in the original, because in the very original 1 minus 4 over x squared, if I were to plug in 2, we would run into issues because that would become 0. So that would make that whole big fraction 0. So it's actually really noting the same thing. But it's a little bit easier to note and solve for after you sort of simplify that complex fraction. Go ahead and try this next one. I would encourage you to sort of pre-factor this initial denominator for this next one, and your least common denominator, as a hint, is going to be a little bit long. So for this next one, to note the least common denominator, so the 1's are just over 1. That doesn't really contribute much to the equation. We've got an x, and then for the x squared minus 9, keep in mind that's going to factor into x minus 3, x plus 3, because that's really the same thing as x squared minus 9 squared. So between x minus 3, and x plus 3, this whole least common denominator is, and let me actually not mislabel that, going to be x times x minus 3, x plus 3. And that's exactly what I want to multiply every single term by. So I'm going to take this, and let me actually write this in a new color. First term times x minus 3, x plus 3. Second term times x minus 3, x plus 3. This term times x minus 3, x plus 3. And this term times x minus 3, x plus 3. So x squared minus 9 is the same thing as x minus 3, x plus 3, so that's going to cancel and make 1. X divided by x is also going to cancel to make 1. And I'm going to be otherwise left with x minus 3, x plus 3, plus 3, x minus 3, x plus 3, all over x times x minus 3, x plus 3, minus 4x. It might be worth noting whether or not this simplifies further. And there's a couple different ways that you could approach simplifying this guy. But I actually think that would be, oh, apologies for my alarm. I think that would be best done by doing some creative factoring here. So in particular, I'm going to notice that here on the top there's actually this multi-term polynomial of x minus 3, x plus 3 that is the greatest common factor between those two terms. So I'm going to go ahead and factor out x minus 3, x plus 3 there. And then what would actually be left as what's different is the x plus 3 right there. So that would be our last parenthesis there, x plus 3. All over. In the second term, we actually have a similar situation going on where they both have an x in common. So that x would actually be their greatest common factor. And then left in parentheses, I'm actually going to see if there's any like terms that combine. So I'm also going to sort of FOIL out what would be left in parentheses. Actually, let me just write out what it is, and then we'll FOIL it second step. So we'd have an x minus 3, x plus 3, minus 4, since that is what is remaining as what is different here between those two terms. Then the numerator looks mostly simplified. The only thing that some people might note is that since x plus 3 is repeated, they might say that's really an x plus 3 squared times x minus 3. For the denominator, we're going to go ahead and FOIL out that x minus 3, x plus 3, which we already know is a difference of squares that's going to work out to x squared minus 9. And then we still have that minus 4. So as a final answer, we've got x plus 3 all squared times x minus 3 times x, and then like terms that combine, negative 9 and negative 4 would be x squared minus 13. And that would be our final beautiful answer. Had anything further canceled out, we would have done that, but there are no common factors left, so that's just our final answer. So go ahead and pause your video and try these next two for yourself. So for this next one, the least common denominator should be x times x plus 2. So we're going to go ahead and multiply each and every term times x plus 2. And then we're going to note what's going to cancel to make 1. So in particular in the denominator, the x plus 2's divided by itself make 1. X divided by x makes 1. X plus 2 divided by x plus 2 makes 1. And so what we'd be left with is x times x gives us x squared plus 4 times x plus 2. All over, all that's left in the denominator is x. Let's go ahead and see if the numerator is going to factor a little bit further just by expanding a little bit. So we're going to do 4 times x, 4 times 2. So we get x squared plus 4x plus 2 all over x. And in this case, there's nothing that's going to multiply to 2 and add to 4. So that would actually just be our final beautiful answer. For the next one, it's going to help to go ahead and notice that denominator here, I'm just going to rewrite that with this, is actually going to factor into x plus 2 times x minus 2, because that is a difference of squares, x squared minus 2 squared in this particular case. So we're going to go ahead and notice that means the least common denominator would be x plus 2 times x minus 2. So we're going to take every single term times x plus 2, x minus 2, times x plus 2, x minus 2, times x plus 2, x minus 2, and then we're going to note what's going to cancel and what's going to be left. So x plus 2 divided by x plus 2 is going to cancel, and I still have x minus 2 left. X minus 2 times x minus 2 is going to cancel, and I'm still going to have x plus 2 left. On this denominator, both the x plus 2 and the x minus 2 are going to cancel, so I still have 4x left. I want to simplify this a little bit further, so in particular I notice that x plus x is going to give me 2x. Negative 2 plus 2 is actually going to give me 0, all over 4x, and then 2x divided by 4x, well, x divided by x makes 1. 2 divided by 4 simplifies to 1/2, and my final answer is simply 1/2, and that actually worked out super satisfyingly, in my opinion. This next one is sort of a similar initial setup in terms of, if you notice, the least common denominator is going to be identical, but the math's going to work out a little bit different because the denominators and everybody are in different places. So that least common denominator is still x minus 2, x plus 2, because we still recognize that first term has a denominator that factors out to that. So we're going to take every single term times x minus 2, x plus 2, x minus 2, x plus 2, x minus 2, x plus 2. And for this first term, we're going to recognize that x squared minus 4 is the same thing as x squared, x minus 2, x plus 2, so we're still just left with a 2x. X plus 2 divided by x plus 2 makes 1, so we still have 3 times x minus 2. All over x minus 2 times x minus 2 makes 1, so we still have an x plus 2. We're going to simplify a little bit further to see if this is going to overall simplify a little bit more, so we're going to distribute a 3 to both terms. 2x plus 3x minus 6 all over x plus 2. 2x plus 3x is going to give us 5x all over x plus 2, and that actually does not factor further, so that's just our final beautiful answer. So just to recap, what you want to do is, and let me actually just write this explicitly, is identify the least common denominator, multiply every term Importantly, every term. If you don't do every term, it's not going to work. By the least common denominator. And then you're going to simplify within the numerator and denominator to see if the whole thing simplifies. That is the recommended way of doing it. Now, you technically can do it the first way, where you simplify within the numerator first, then do the overall division. But for most of these problems, being in the habit of just clearing all the denominators is going to be a much smoother way of approaching the problem.